everyone. Welcome to STEAM for Tweens. I'm Miss Jennifer here at the Warrenton Library. In today's program, we are going to do some card tricks that work based on mathematics. Magicians call this kind of trick a self-working trick. If you follow the steps in the right order, then the magical effect is guaranteed to happen. If you picked up your supplies here at the library, you'll have everything you need to complete this activity, except for paper and pencil. And if you didn't get a bag, you'll also need a deck of cards. So everyone, welcome Ms. Peeling. She's here to be my lovely assistant today, and we're going to be doing some magic tricks together. So let's start off. I'm going to turn the camera down so that you all can see the tabletop, and I'm going to show you what I am showing her. So I have 5 cards in a red suit, hearts in this case, ace through 5. And I have another set of 5 cards, ace through 5 in spades. And Nancy, what I'd like you to do is to take these 5 cards or those 5 cards and set them on top of each other, whichever one you want. Take one stack and set it on top of the other stack, face up. Perfect, very good. All right, now I am going to take these cards and I'm going to give them a little bit of a shuffle. So I'm just going to mix them up a little, just like that. Why don't you tell me where you'd like them to be cut? Anywhere you there. There, okay. So I'm going to stop and cut the deck. And now I'm going to deal down 1, 2, 3, 4, 5, and set the other stack right next to it. So now you get to make some decisions. You can change the place of 4 cards from either stack. So you can do 3 from this one and 1 from this one, 2 from each, 4 from just one, however you'd like. And what that means is you're going to move the top card to the bottom of the pile. So where would you like to make those changes?
I'll make 2 on each.
Okay, so we're going to move 1 here and here, and 1 here and here. All right, now we're going to take these top 2 cards and just set those aside. And we're going to go again. This time we're going to make 3 changes.
Okay. 2, 1.
2 and 1. Okay, 1, 2, and 1. And now we're going to again take these top 2 cards and set them aside. And now we're going to make 2 changes.
1 and 1.
1 and 1. You got it. 1 and 1. And set these aside. All right, 1 change. What would you like for it to be? This deck. You got it. 1 and set them aside. So let's see what we have here. We have a pair of 5s, but we also have a pair of 3s, a pair of 2s, a pair of aces, and a pair of 4s.
How does that work?
All of the cards match themselves back up into pairs. So that is our first trick of the day, and I'll tell you how it works in just a minute. So let's talk about how our first trick works. Remember, we started out with 5 cards of a red suit and 5 cards of a black suit. Now, these are in order ace through 5, and we had our participant take 5 of them and put them on top of the other. We did a little bit of shuffling, moving cards from the top to the bottom on either stack. And we let them do that 4 times and then took 2 cards away. And then 3, 2, and 1 swap from either deck, moving cards from the top to the bottom and setting the top 2 aside. And remember, all 5 pairs ended up matching at the end. So this works by the power of math. If we stack one pile on top of the other, but keep them spread out so that you can see them, you see that they make a series, 5, 4, 3, 2, ace, 5, 4, 3, 2, ace. Now, if you imagine that this is a circle rather than a line and make it look like a clock, then this is a cycle that just keeps repeating. So we go ace, 2, 3, 4, 5, ace, 2, 3, 4, 5, all around and around in a circle. You can stop that circle anywhere you want to, but the series and the order will still be the same. So when we cut our deck and move some of the cards to the bottom, and we had a cut say here, and we moved a whole stack of cards, if you flip those over and you take a look, then they're still going to be in our series. They're just going to be in a slightly different order. So we have some of, in this case, we have one of our black cards at the front, and we have the rest at the bottom. But remember, we're still dealing with a circle here. So the order of the cards doesn't change. And I can show you that in a linear way here on our whiteboard. I've written out ace, 2, 3, 4, 5 in our black suit, and then ace, 2, 3, 4, 5 in our red suit. And we're going to cut the deck, and we're going to represent that with this slash. And then we're going to move these cards over to the front of the pile. So we now have 3, 4, 5, ace, 2, 3, 4, 5, ace, 2. So see, the cards are still in the same series. We've just moved where the series starts, but they still go in the same order. Now, our next step was that we dealt 5 cards down, and that was from the top of the pile. So this front half ends up flipping. So we now have 2, ace, 5, 4, 3. All right, so it's the same cards in this order, but we dealt them down so that this card ends up on top. And then we have our other stack that we just set down next to it, and those cards don't change order. So we have 3, 4, 5, ace, 2. So these are the way that the stacks look when we started doing our shuffling. And remember, we had Nancy move cards from the top of the pile to the bottom of the pile. Now, right now, we don't have cards that match, but when we're done with our moving them around, they will match. So we are going to have 4 moves because we have 5 cards. We always want to move 1 card less than our total. So the first time we had her move cards, she moved 4. And remember, they can be from the top 2 or top 2 here, 3 and 1, it doesn't matter, but they'll always end up matching. So let's say that we move 2 cards here and 2 cards here. All right, so our top 2 cards go to the bottom, and what's our next card on each pile? They match. There are 5. And that's going to happen every time you do this trick, if you're doing it correctly, because of the power of math. The next card is always the same number of swaps away, as 1 less than the total number of cards in your pack. So this works based on clock arithmetic or modular mathematics. In modular arithmetic, numbers wrap around upon reaching a given fixed quantity, which is known as the modulus. So the best way to think of that is to picture a clock, and the modulus would be 12 at the top of the clock, and we determine the time around that 12, or 60 in the case of minutes or seconds on a clock. If you have some cards in a particular order and you cut the deck only by moving the cards from the top to the bottom, you will change the position of the individual cards, but not the sequence. The next card down will always be the next card in order, with the whole thing wrapping back around, just like a clock. Each card's match is always just 5 cards away in the sequence. Cutting the deck in half and dealing the top cards down reverses the sequence. Now, instead of having the same positions in the pack, pairs have mirrored positions, which we saw on our whiteboard. If we look at the 5, for example, like we did here, its pair is always 1 less away than the total number of cards. So in this case, we had 5 cards, we moved 4 times, and that brought the 5s to the top. So this trick will guarantee matching pairs every time. So now we're going to move on to trick number 2. And this one requires a whole deck of cards. All right, and we're going to spread them out on the tabletop so that you can see all the cards. And this takes a little bit of time and effort to do, so that you can make a decision. All right, Nancy, I would like you to choose somewhere where we can cut the deck about in half. Right there? Okay, so we're going to take this half of the deck and just set it aside. And we're going to be working with this stack. And now I'm going to do a special kind of deal. It's called a down under deal. And I'm going to show you how that works. It goes down, under, 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 down, under. We're going to take the down cards and set them aside. And now we're going to go again. Down, under, down, under, down, under, down, under, down, under, down, under. Take the downs, set them aside. We're going to go again. Down, under, down, under, down, under. Set those aside. Down, under, down, and set those aside. And now we have one card left. It's the 8 of hearts. Now you cut that deck anywhere you wanted, right?
I did.
And we did our down under deal. But before we started today, I made a little bit of a prediction, and it is down under my mat here. Will you please open up your envelope and see what's
Envelope,
inside?
Please.
And hold that up so we can all see the 8 of hearts.
I am gobsmacked.
That's our final card. All right. And now we're going to learn how that works. For our second trick, remember you needed a deck of cards, in this case without the jokers, and then you need to use your paper and pencil to write down the words 8 of hearts on a piece of paper, and then take that and put it out of sight of the person that you're doing the trick for. In my case, I had this envelope and an enlarged copy of the 8 of hearts. That was just for effect. You can do this just as well with just a piece of paper and pen. You're going to take your deck and you're going to find the 8 of hearts. Let's see. And you're also going to find the ace of hearts. And those are going to be your two important cards to keep an eye on, because those are going to tell you where you're going to be splitting the deck. So you have your ace of hearts and your 8 of hearts, and they're going to be your benchmarks in your deck. So we're going to place the 8 of hearts in the 16th position of the deck. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and add in your 8 of hearts, just like that. So that was our 16th. We're going to go 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and then we want the ace of hearts to be our 32nd card in the deck. All right, so we're going to put that in, and then we're going to put our deck back together just as normal. So this trick requires a little more preparation than the other one. You want to stack your deck per se, and have your 8 and your ace where you want them to be, and you need to write that 8 of hearts down on a piece of paper, and make sure that you hide it so that the person that you're doing the trick for can't see it. Remember, we spread the deck out on the table so that the whole deck could be seen, and we let our participant choose where to cut the deck. Now, this part is a little bit of a trick. You say that you want them to cut the deck anywhere that they please, but really you're getting them to cut it roughly in half, and you want to make sure that they cut it after the 8 of hearts, because we want the 8 of hearts to be in the part of the deck that we use to do the trick. So if they say they want to split the deck here, that's not going to work. And if they want to split it, so you want to get them to split it somewhere roughly in the middle between the 8 of hearts and between the ace of hearts. See, that ace is here and the 8 is here. Now, you can guide your participant a little bit in this by sort of putting your hands out and putting one on top of the 8 and one on top of the ace, and sort of manually gesturing to indicate that you want it to be in the center. And then I also actually came right out and said that we want to make sure that the cards are roughly in half. And so that gave a verbal cue to Nancy that she was meant to choose somewhere in the middle. And so now she chose about here, and we set this half of the deck aside, and we just worked with the part of the deck with the 8 of hearts in it. And it doesn't really matter how big your deck is at this point, as long as your 8 of hearts is in it. And so we flipped the cards over and we started doing our down under deal, remember? And that's just a funny turn of phrase because I was letting her know that I was preparing her for the idea that the answer to the trick was down under the mat, but we're also flipping half of the deck and leaving half of the deck alone. So it sort of explains why we're putting one down and then flipping another. We're calling it down under. Okay, so let's take a look at how that works down at the table. I'm going to start my down under deal. Down, under, down, under, down, under, down, under. You want to start your rotation with down and then go under. Down, under, down, under, down, under, down, under, down, under, down, under, down. And this will take a varying amount of time depending on how big your deck is, but just keep going. You can even maybe say this is not the most exciting deck way of dealing to watch, but it will be effective in the long run. And so we're going to discard our down pile and keep going with our under pile. And this is the set of cards that's face up. And you'll see right here that the 8 of hearts is in it. And we're going to go again. Down, start with down, under, down, under, down, under, down, under. There's our 8 of hearts, under, down, under. We're discarding down again. And you always will notice as you continue with this that your 8 is going to be face up in your under pile. Down, under, down, under, down, under. There it is again. Discard down. We're going to go again. Down, under, down. Discard down, and we're left with our 8 of hearts. And this works every time. And that's because we have positioned the card in the 16th slot. And that trick works by what a computer scientist would call an algorithm. An algorithm is a series of steps that that you can follow to guarantee to achieve some desired effect. A simple version of the algorithm for this card trick would be written out as 1, place the chosen card in position 16, in this case, the 8 of hearts. 2, discard roughly the bottom half of the deck, which we did when we split, when Nancy chose where to split the deck. 3, repeat 4 times the following. Discard the first and then every second card thereafter. And that's what the down under deal accomplishes. We down, under, down, under. And so we are going to be discarding roughly the bottom, or excuse me, the first and then every second card thereafter. So we discard the first because that's going in our down pile. Under is staying up. Down, there's our every second card thereafter, under, down. So this algorithm will then reveal that the card left is the card that you predicted. This trick works because as long as there are no more than 31 cards, by repeatedly discarding every second card, you are guaranteed to end with the 16th card. This only works if there are no more than 31 cards there at the start, as otherwise the 32nd card would be the card left. And then you'd have to deal the 16th card down and it would go away, leaving the 32nd. So it's all just part of mathematics and making sure that you are putting the cards in the right position to end up with the one you want at the end. Now for our third trick, we're going to need, again, our deck of cards, and they can be shuffled in any order. Just give them a nice shuffle, toss them, cut them, whatever sort of order you want them to be in, it doesn't matter. And we're going to deal out 2 piles. We're going to have one down and one up through the entire deck. So this might take a little bit of time, but this is just the setup of the trick. And then you'll see something fantastic. We are going to try to use the power of our minds to influence what happens to the cards. Okay, so we are going to leave this deck face down and pull this deck to the front, face up. I'm going to take this deck. Nancy, I'd like you to take this deck. Don't look at the cards. Just hold on to your deck. And I'm going to hold on to mine. And we're going to think really hard together. And I am going to take a certain number of cards from my deck and have you take a certain number of cards from your deck. Mine are all going to be the same color. You won't know what yours are. We'll just have to work it out. Now
We
you
take
can,
them from anywhere.
yes, you can take them from the top of the pile, the middle of the pile, the bottom, whatever you feel in your mind are the right cards to choose. All right, so I'm going to take 3 red cards and put them down in a pile. Now you take 3 cards, any 3 that you like from anywhere in the deck, and set them face down, yep, right next to them. 1, 2, 3, very good. All right, now I'm going to take 1, 2, 3, 4, 5. That feels like a good number. 5 black cards and set them right here. And you choose 5 cards from anywhere in your deck.
1, 2, 3, 4.
Very good. And set those right over here to the side. Very good. And we're going to keep going and do this again. Let's say 1, 2, 3, 4 red cards. I'm going to add to this pile here. That is. And you
Okay.
have 4 cards in that pile there.
1, 2, 3, 4. Here.
Yes. And then 1, 2, 3, 4, 5, 6. Let's do 6 black cards for me and 6 cards for you.
2, 3, 4, 5, 6.
Very good. And those go there. Perfect. All right. I'm going to do 1, 2, 3, 4, 5, 6, 7 red cards. So you choose 7.
1, 2, 3, 4, 5, 6, 7.
And those go there. And 1 black. And you have 1 black goes right on this pile. Perfect. There you go. All right. So hopefully, through the power of our minds, we have influenced how many cards are in each of our decks here. So I have a pile of black cards here and a pile of red cards, and these we don't know, but I am willing to bet that the number of black cards in this pile is the same as the number of red cards in that pile. So why don't you count the number of red cards in your pile there?
1, 2, 3, 4, 5, 6, 7.
7. All right, and now count the number of black cards in that pile.
Where does that one go?
That you can just set that down on the table and take a hold of these.
Oh, okay.
And we're going to count the number of black cards in that stack.
Okay.
And I'm willing to bet we're going to get
1, 2, 3, 4, 5, 6, 7, 8, 9.
No, I think you miscounted. Let's try to 1, 2, 3, 4, 5, 6, 7. There you go. So we have 7 black cards and 7 red cards have managed to find their way into our mysterious piles. And that is our third trick. Let's see how it's done. Of course, it's not mind melding. It's just computation and mathematics. The trick is self-working. If you follow the steps, it's bound to work. Let's look at why using algebra. We're going to use letters to represent numbers. We're going to call the piles that we dealt R1 and B2. R for red, B for black. The other 2 piles from the sides, and in this case, I've split them in half so that we have the red cards and the black cards. But remember, these were just singular piles here to the side. These piles contain a random mixture of red and black. So let's say that the pile here next to R1 contains R3 reds and B3 blacks. And the pile here by B2 is R4 reds and B4 blacks. A full pile of cards, a full deck of 52 cards was used. It contains 26 red cards and 26 black cards. If you add up the red cards in the 4 piles, it will come to 26. We can write that as an equation using the names R1, R3, and R4 for the different sets of red cards in each pile. So we have R1, R3, and R4. We can also do the same for the black cards. Remember, we have to use these letter number combinations because we don't know the actual number of cards in the deck. So we're going to have B2, B3, and B4. And we can use our whiteboard here to represent that mathematically. So we know R1 plus R3 plus R4, that's all of the piles that have red cards in them, equals 26, because that's half the deck. And we know that B2 plus B3 plus B4, which are all of the piles with the black cards in them, have, again, 26. And now we know something else about these numbers. Whenever we put some number of cards in the red pile, we put the exact same number of cards face down. Remember, so I chose maybe 5 red cards from my deck, and then we had Nancy choose 5 cards at random from her deck. So the number of cards in the deck that I put down and the number of cards in the pile that Nancy put down were the same. This means that the 2 piles end up with the same number of cards, though again, we don't know what that number is. In terms of our names, that means that we know that the number of cards in R1 is the same as the number of cards in B3 and R4 together. So B3 plus R3 must add up to R1. Similar reasoning holds for the cards in front of next to the black pile. So we know that B2 equals R4 plus B4. And when we write that up as an equation, that looks like this. So we know that R1, the number of cards I put down, is the same as R3 plus B3, which are the cards that Nancy put down. And then the same holds true for B2, which equals R4 plus B4. All right. So we can start working this out mathematically by combining these equations and swapping things for equals. For starters, we know that R1 is exactly the same as R3 plus B3. We just proved that. So we can replace R1 by putting R3 plus B3. Also, similarly, we know that B2 is the same as R4 plus B4. So we can substitute that information in as well. So this is the same equation. We've just swapped out that information. And we're going to combine this so that we can start breaking down our equation a little bit. Because we know both of these equations equal 26, we can set them up next to each other in a long line so that we see that R3 plus B3 together plus R3 plus R4 equals 26, which also is represented by R4 plus B4 together plus B3 plus B4 equals 26. So we turn it into one big long line, and now we're going to simplify it. All right, so we have simplified our equation a little bit by grouping the same things together. And now we can start noticing things that are the same on both sides of our equal sign. So in this case, we have R4 and R4 on both sides. So we can eliminate those and start simplifying things. We also have B3 and B3 on both sides. So we can remove that. And that leaves us with 2 times R3 equals 2 times B4. We can divide both sides by 2 because we have 2's on both sides. And that tells us that R3 equals B4. And that is our mathematical proof that the number of cards, red cards, in our dealt face down pile, and the number of black cards in our face down black pile will be the same every time because it's a self-working trick. I hope that you enjoyed our program today. Stop by the library to check out more books on simple math and card tricks. Next month's program, we'll learn about geology using candy bars. Don't forget to register for a supply bag so you can pick up everything you'll need to participate. In the meantime, head over to our website, fauquierlibrary.org. Click on the research button and select Science, Math, and Environment from the list shown. There you'll find Science Online, a resource source featuring articles, videos, experiments, and activities to enjoy on a range of scientific topics. Thanks for watching.